Good afternoon. I'm spot on weather meteorologist Matthew Euler, and today we're going to go over a weather lesson. And this lesson is going to be over the winter precipitation types, ranging from snow to sleet and to freezing rain. So let's take a look at the differences and what causes these different precipitation types. Let's start off with snow. All right, so what I have here in this diagram is anything, it's basically a vertical temperature profile from the surface down here all the way up into the upper atmosphere. The red line represents the temperature of the environment. All right. And then the scale on the bottom tells you whether we're below freezing, less than zero, or to the right, we're above freezing. Okay. So let's take a look to see what's happening here. Anything again to the right of this zero vertical line, all right, is greater than 32. Anything to the left of this is less than 32. All right, so the first thing what we have happening with snow is I want you to imagine there's a cloud base above this diagram here. All right, precip begins to fall out of this cloud base, precipitation, in the form of these solid states of matter, solid particles, or ice. We call them snowflakes. All right, and the snowflakes go from the cloud base, which would be up in this area, and keep falling and falling and falling closer to the ground level down here. And in this case, the temperature of the environment basically remains below 32 degrees Fahrenheit. You notice how the red line stays to the left of this 0 degrees Celsius line here. So this is remaining below freezing. Air temperature is below freezing throughout the entire depth of the atmosphere in the case of snow. So it has no chance really to melt as it falls from a cloud base down towards the ground. And temperatures, again, just to re-summarize, are below freezing for the entire journey from the cloud base to the ground, allowing snow to remain intact. All right. Now moving on to sleet. With sleet, it's a little bit different. In the case of sleet, you have 32 degree line is this blue vertical line represented by the 32 degrees Fahrenheit down here. Anything over to the right of this line is warmer than freezing. Anything to the left of this 32 degree line is less than freezing. Okay, so we have a cold layer. And again, I want you to imagine that the cloud is right up here. Okay, you have a cold layer immediately beneath the cloud base. Then you have a shallow warm layer. And notice that the shallow warm layer, you have a little bit of a layer in the upper atmosphere above the surface of the Earth. It's above freezing, above 32 degrees Fahrenheit. Okay, and then at the bottom here, you have another cold layer closer to the ground. I'll say, okay, so with the case of sleet, precip starts out as snow, as a solid. Imagine the cloud base is up here again. The particles will then descend out of the cloud base into this cold layer, which is below the freezing point to the left of this blue 32 degree line. All right, and they start off as snow. And as they leave the cloud base, they fall into a region of this below freezing air here, the cold layer. And as a snowflake falls, it encounters a shallow warm layer, which is above freezing, which is indicated by this little sliver, this green area here, to the right of the 32 degree Fahrenheit, just above freezing line right here. All right, so as that snowflake encounters that shallow warm layer, which is above freezing, it partially melts. And finally, this partially melted snowflake will then, as it continues to descend, partial melting occurs in this layer, but as it gets closer to the ground, it runs into another layer that's below 32 degrees Fahrenheit, and it's much colder here. And what happens is that partially melted snowflake then encounters that cold layer and becomes a sleet pellet. It refreezes. And then that sleet pellet, the one thing you could tell sleet, how you could tell sleet in the wintertime is as it falls, it bounces off of objects like parked cars, grass, etc. Now, just keep in mind that whenever I refer to a cold layer, I'm referring to a layer that's below 32 degrees Fahrenheit, the freezing point. And when I refer to a warm layer, I'm referring to a layer that has temperatures above 32 degrees Fahrenheit, above freezing. this is a picture here of how things start. You have these snowflakes again that fall from the cloud base into the cold layer, and then partial melting occurs in the shallow warm layer as that snowflake descends down towards the ground, and then they refreeze. The particles refreeze upon entering this other cold layer closer to the surface. And finally, one of the more trickier precipitation types out there. It's very tricky to forecast. It's very challenging. And I've actually seen freezing rain at less than 32 degrees Fahrenheit when the temperature is that cold, basically 28, 27 degrees Fahrenheit. You can still see freezing rain, by the way. But freezing rain is one of the costliest and the most dangerous, especially when it comes to driving. So what happens with the sounding with freezing rain? Okay, so again, imagine the cloud base is up here, all right, and this area from this point to that point, this slice here is below the freezing point. So it's initially a shallow cold layer right beneath the cloud base. So the precip falls as snowflakes as a solid coming out of the cloud base, descending toward the ground. And then look at this. In this case, with freezing rain, the snow will melt completely, all right, because you have a thicker, a greater depth of the atmosphere, very thick layer of elevated warmer air for that snowflake to have complete melting. So there's complete melting here. It becomes a cooler raindrop, a cooler cloud water droplet. And as it continues to move down towards the ground, it encounters a very shallow layer closer to the surface that is below the freezing point, below 0 degrees Celsius. And that's when things freeze. The liquid will then, these water droplets become supercooled and freeze immediately on contact with all surfaces. And again, this is a very dangerous type of precipitation in the wintertime. Just to sum it up here, here's what I have. Precip initially starts as a solid, as I'd mentioned, as a snowflake. As it leaves the cloud base in a layer that is below freezing, and as a snowflake falls, it encounters a deeper elevated warm layer that is above freezing, and the snowflake melts completely. The cool water droplet then encounters a very shallow layer of sub-freezing air closer to the surface, resulting in immediate freezing upon contact upon all surfaces. So notice the difference between freezing rain, right? So we have a much thicker warm layer with freezing rain and a much shallower cold layer below freezing at the surface as compared to sleet, where you have a not such a great depth of elevated warm air, and the cold layer near the surface is a lot thicker too. So therefore, with sleet you have partial melting. With freezing rain you have complete melting. All right, and in Southeast Virginia in the wintertime, we get quite a bit of events that have freezing rain. So the frequency of freezing rain, this chart shows you what it is. All the rosy colors, the pink, the maroon, the red, the yellow, those are all very high frequency areas that get freezing rain, climatologically speaking. Also out here in the Pacific Northwest in valley areas. And then anything that's lighter pink or orange typically does not see much freezing rain. But you see where the concentration is of freezing rain? The Midwestern United States, there's a little bullseye in Missouri, Illinois, Iowa. And then look at Virginia here. All right, we get this fairly frequently here, and I'll explain why in a minute. Eastern Canada also gets some pretty bad freezing rain events, and they can have some pretty significant ice storms. So the greatest concentration on this chart, on the map, you'll notice that it's in the Midwestern United States, the Eastern United States, including New England and Eastern Canada. And freezing rain typically occurs when warm air overruns colder air at the surface as solid precip falls an elevated warm layer. And it's typically associated with warm fronts. That's where the warm air overrunning generally happens, where that warm air overruns colder air at the surface. Cold air damming east of the Appalachian Mountains, freezing rain typically happens with cold air damming events east of the Appalachian Mountains as warm air overruns a cold air wedge. It's called a cold air wedge. So what happens in wintertime, a lot of times you have high pressure up here to the north, clockwise flow around it will funnel in much colder air down in basically to the east of the Appalachian Mountains. And what it does is this cold, dense air flows all the way down into northeastern Georgia. And it gets trapped. It's so dense, it just basically gets trapped. It's hard to remove the cold, denser air from the surface because it just goes right down the natural topography to the east of the Appalachians. So it's very important with cold air wedge events. We look at that frequently in Virginia to kind of determine the precipitation type. You'll hear the National Weather Service refer to it as a cold air wedge, cold air damming. So that's why there's a lot more ice and freezing rain events here against the Appalachian Mountains. All right, and then notice the increased frequency, 20 to 30% during the winter time in southeastern Virginia. Erosion of cold air mass when wind blows off the Atlantic, increasing temperatures from the ground to 5,000 feet. This is the reason we get freezing rain a lot of times in southeast Virginia, is you get the winds that come in off the water that tend to erode away the cold layer that was in place. Once those winds come in off the water, it warms the planetary boundary layer, our lower level of the atmosphere where we live, and snow typically will switch over eventually to a freezing rain and then a lot of times to a colder rain. So here's an overrunning situation diagram just to show you. Warmer air is less dense than colder air, so therefore warmer air will move up and over the colder air at the surface. And here's your colder air further away from the warm front at the surface. Typically you'll go from a snow. As the warm air gets closer to your station or location, you'll go to a sleet, then possibly to a freezing rain, and then to a rain. And many times across southeastern Virginia, closer to the coastline, you will see precipitation start out as snow, change to sleet, freezing rain, and then ultimately to cold rain. And I have observed this personally from driving from Norfolk to the south side of Chesapeake, Virginia Beach area before, back in 2010. I literally was going through, leaving Norfolk, and it was snowing, and then as I was driving down the interstate, I ran into sleet pellets bouncing off of my windshield in my car, eventually changing over to a freezing rain briefly, and then just a plain rain by the time I got home. It was really wild that day to be able to see the whole changeover from snow to rain in a matter of 8 miles. All right, so for overall summary, just a quick look at this. We're going to wrap this up. Below freezing all the way from the cloud to the ground for the temperature profile will give you snow. Sleet, you have a deeper freezing layer closer to the surface and a more shallow, elevated warm layer for partial melting. Freezing rain, you have a deeper elevated warm layer aloft and a more shallow freezing layer at the surface, so that results in freezing rain. And then plain rain is when the temperature profile all the way down to the surface is completely above freezing. Hopefully you enjoyed this lesson on winter precipitation types and it makes sense. Forecasters typically look at the temperatures aloft from the surface all the way up 5 to 10,000 feet to determine what type of precipitation could occur in winter type situations. So that is all I have for now. Spot on weather. If we're not spot on, we're not doing it right. Have a great afternoon, everyone.